Good day, learners. Welcome to Technical Sciences lesson. My name is Zamisile Mdima. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. So once more, we're going to be looking at paper 1 revision since we're heading towards the exam date. So we can never do enough revision. We're just going to keep on doing the past question papers as much as we can possibly can so that we master how to best analyze the question, best interpret what is it that is being asked to us, and then give the best responses ever. Okay, so the last time we covered paper 1 content, but we did not finish all the chapters. Okay, so today we're just wrapping up paper 1 content as a whole by looking at the chapters that we did not cover the last time. Those chapters are magnetism, electrostatics, as well as electric circuits. Okay, so this is the last lesson that we are doing paper 1 content. All right, so we're just going doing a lot of emphasis on those chapters that we just mentioned. All right, so main objective by the end of the lesson, what is it that I want you and I to be comfortable with? I want us to be able to analyze the multiple choice questions. I want us to be able to solve problems involving magnetism, to be able to use Coulomb's law of electrostatics to solve problems that are involving the interaction of the charges, as well as to be able to interpret, analyze, and to be able to solve problems involving electric circuits. Okay, so at the end of this lesson, I want you and I to be able to best be able to do all these 4 points as stipulated. Okay, so let's begin with the multiple choice questions. All right, so we're going to have 10 multiple choice questions, and then we're going to look at how best can we analyze them so that we are able to get rid of the distractors in the question, being able to pinpoint which one is similar to the answer, which one is the answer, okay, by looking at the 4 options that are provided to us. Okay, this is a multiple choice question 1.1. It's taken from the previous question papers. It says, which one of the following will increase the strength of the electric field E between the 2 parallel oppositely charged metal plates? Okay, so you've got 2 oppositely charged metal plates. Okay, you got your positive, you got your negative as well. But now we're looking at the one that will increase the strength of the electric field, which is capital letter E. Okay, so what is it that we should do to be able to increase the strength of the electric field between these 2 parallel oppositely charged parallel plates? Is it A, increase the area between the plates, or B, increase the distance between the plates, C, increasing the potential difference across the plates, or D, decreasing the potential difference between the plates? Okay, so some of the answers you just need to be able to write the formulas, because as we are given the formula sheet, it helps us to be able to understand all the physical quantities that are there so that we best be able to choose the correct answer. Like on this one, we just need to understand the relationship between all the variables that are there when we have to calculate for the electric field strength. Okay, so we say E is equals to V over D. Okay, so what it means is that E, which is your electric field strength, is directly proportional to the potential difference. Okay, so if you wanted to increase the electric field strength, therefore that means that the potential difference also needs to increase. Okay, so that is why this formula says nothing about the area, so definitely it is out. It says, okay, it does say something about the distance, but now what is the relationship between the electric field strength and the distance? It's inversely proportional. Okay, so meaning that as you increase this one does decreases. So but in the option that we are given, it says increasing the distance between the plates, so it is not the correct answer. Okay, option C is saying increasing the potential difference across the plates. Okay, which is very good, because now if we want to increase this, that means we have to increase this one. But why are we saying that? Because now the electric field strength is directly proportional to the potential difference across the plates. And then option C is saying decreasing the potential difference between the plates. No, because that now is not stipulated in the formula that we are using. Okay, so it just goes against the formula, and it goes against how we should be doing things. So this one is wrong. So by knowing the physical quantities that are there in the formula that is provided to us at the back of our question paper, we can use it to then interpret it and then get the correct answer. So that is why the correct answer is option C. Okay, so by us equipping each other with the skill of how to best give the good answer in the multiple choice, or the correct answer in the multiple choice amongst the 4 options that are provided, is that you need to be able to look at what is it that are distractors. What are the options amongst the 4 that are given to us that are distracting us to getting the correct answer, and then what is it that is similar to the answer. Okay, so if you're looking at your option D is similar to the answer, but the keyword there, it's decreasing, that it just throws us out, because then now it doesn't show the direct relationship between the electric field strength as well as what the potential difference. Okay, so that's how you should move on about answering your multiple choice questions. So the second one, multiple choice question 1.2, a bar magnet is cut along a dotted line shown below into 2 pieces marked A and B. All right, and then a learner tries to reassemble the magnets by bringing the cut sections into the of the magnet close to each other. Now, question says, which one of the following will happen when the 2 cut sections are brought close to each other? What was it that will happen? Okay, so a cut section to A and B, will they repel? Okay, or will they attract? Or option C, attract and then repel, and then option D, exert no force on each other. Okay, so definitely D is out, because there cannot be no force that is being exerted towards each other. Okay, so initially these 2 are pieces of magnet. Okay, remember what we said about pieces of magnet. No matter how many times you crush it, okay, that even small piece will have a north as well as the south, because now originally these were just close, they were just close to each other. Okay, they were embedded on each other. Okay, so they had this force of what? A force of attraction. That means this piece over here has got a north and the south. This one has got a north and the south. So if I can just write it on top of here, north and the south pole, and then there's a north and then the south pole. Okay, so that means because these are unlike unlike poles, because in this instance we're talking about poles, so they're going to do what? Have that force of what? Of attraction. So the correct answer is B. Okay, moving right along on MCQ, rather multiple choice question 1.3, 2 positive point charges. Okay, I want us to read it slowly on that part, because that is very important. 2 positive point charges Q1 and Q2 are placed at a distance of 2 meters apart. Okay, so that means these 2 have got the like charges. Okay, so it's positive and positive, and we know that when the charges are like, meaning they are the same, they're going to repel. Those charges are going to repel, whether be it is a positive and a positive, or a negative and a negative. So they're going to repel because they are like. But when we have unlike charges, so a positive and a negative, so they're going to do what? To attract. Okay, so in this case, both Q1 and Q2 have a positive point charge. All right, and they are separated by a distance of 2 meters apart. And then F1 is the force exerted by Q1 on Q2. All right, and then F2 is the force that is exerted by Q2 on Q1, and Q1 is greater in than Q2. So this is just telling us about the magnitude of Q1 and Q2. Yes, we do know both of them are positively charged, but Q1 has a bigger magnitude than Q2. Okay, so it says now, which one of the following statement is correct about the magnitude of the force and their nature? Okay, so the force that exists between these 2, Okay, but in this case, it's going to be a force of what? Of what? Of repulsion. Why? Because the charges are like, meaning they are the same. Okay, so in the nature, so already in the options that are provided, we're looking for what? For repulsive nature. So it can never be A, it can never be B. Okay, because those are giving us attractive nature, or the force of what? Of attraction between the two. Okay, and you want to find out about the magnitude of the forces. So this, it can be between option C and option D. Okay, but now it says option C, F1 is equals to F2, which is very correct, because the force that is being exerted on either the charges is going to be what? Is going to be equal. And then option D is saying force 1 is greater than F2. No, the statement just said the magnitude of the what? Of the charges is the Q1 that is greater than Q2. Okay, but the force that is being exerted will have to be what? To be the same. That is why option D is wrong, and then option C is our correct answer. Okay, so that's how we go on about analyzing the multiple choice questions. Please make sure to read all the statement that is given to you, because that is where you are likely to get the hint of what the correct answer is exactly. Okay, multiple choice question 1.4, the opposition to the flow of electric charge is called. So this is more like a definition. So it's more about remembering, reminding yourself, what is it that opposes the flow of electric charge? So remember, what is a flow of electric charge? It's current, right? So it's the rate at which the charge is flowing, okay, in the electric circuit. But now, what is what that provides that opposition? Okay, definitely not the EMF. Okay, definitely yes on the resistance, no on the capacitance, and then no on the potential difference. So the correct answer is option B. Okay, multiple choice question 1.5, in the circuit represented below, all the bulbs are identical, so they are the same. All right, a voltmeter connected across bulb 1 reads V. Okay, so if we were to connect it here, it will read, will read V. All right, what will be the reading on the voltmeter be when it is connected across bulb 3? Okay, so if we were to connect it here, what will be the reading on that one? Okay, so let's look at how it is connected like that. So remember, these ones are just connected in what? In series, and you know that there are potential difference dividers. Okay, and then the ones that are connected in parallel, they are what? They are current dividers. Okay, so definitely a voltmeter connected across bulb 1 reads V. What will be the reading on the voltmeter when it is connected across the bulb 3? Okay, so definitely it will not be 0. It will not be V, because that will mean that it is exactly the same as that one, because now remember, there are potential difference dividers, so this V will have to be divided amongst all of them. So this means that the correct answer is what? It is C, because it's giving us a V over 2. Okay, multiple choice question 1.6, astronauts in space are at risk of being irradiated by the solar winds because they are, okay, so when the astronauts are in space and they're not on Earth, okay, so they have moved far away from the magnetosphere that is covering and protecting everything that is on Earth. Okay, so they're looking at the Earth as a far distance. Okay, so they are at the question says that they are at risk of being irradiated by the solar winds because they are inside the magnetosphere. No, because astronaut, we know that those people are going to where? To the space. Okay, they are not inside the Earth, and we know the magnetosphere is the magnetic field that is surrounding and protecting every living organism that is being what? On Earth. Okay, so definitely it's not A. B, inside the Earth's gravitational field. No, because they are outside the Earth. okay, the planet Earth. They are looking at planet Earth like, okay, here you are right here amongst all the other planets as well. So definitely not a B. So they are outside the magnetosphere. Yeah, they are at risk because they are outside of it. So there's no way that this Earth's magnetic field can be able to provide protection to them because they've stepped outside of it. So definitely it is option C. Okay, but let's look at D as well. Outside the Earth's gravitational field. No, because now, yes, even in as much as they are outside the Earth's gravitational field, because the gravity is given inside the planet Earth, but the most important thing is that those solar winds, or rather the magnetic field surrounding the Earth, is providing protection against these solar winds. Okay, so with specifically towards the question what is asking, the correct answer is C. Multiple choice question 1.7. The force between the two magnets, okay, decreases. The force between the two magnets decreases when does the force decrease? Okay, let's imagine. So you've got this is your one magnet and this is your other, and then as you try to pull them closer to each other, okay, so what happens that as you are pulling them closer, the distance decreases and the force increases between them. But now as you are pulling them apart from each other, what happens is the force that is exerted between this magnet and that magnet is going to what? Decrease. Okay, what is happening here? The distance has what? Increased between these two magnets. Okay, so we're looking for, because now when the force between the two magnets decreases, so we're looking for the second scenario which I made. Okay, so because in this case when the two magnetic poles are right far apart from each other, the force in between them decreases. So they decrease when the distance between them has done what? Has increased, has enlarged. Okay, so now A, two like poles come closer together. Definitely no, because when they come together, okay, and they are like poles, they're just pretty much going to do what? To repel. And also the distance between them has done what? Has become shorter. So definitely not A. Two unlike poles come closer together. No. The distance between like or unlike poles increases. Yes. And then option D goes on to say the distance between like and unlike poles decreases. No, because we're looking at when you are pulling them far apart from each other. So definitely it is option C. When if we were to complete what the sentence is saying, we'll say the force between the two magnets decreases when the distance between the like or unlike poles. And yes, we are including this like or unlike because it could be a force of attraction. They did not specify as to what type of force, a force of attraction or repulsion, because it can either or be the repulsion or attraction. So but the bottom line is that the distance does what? Increases between the two magnets. All right, multiple choice question 1.8. Which one of the following statement is correct regarding a positively charged object? What is it that is regarding to be correct about a positively charged object? A positively charged object has only protons and no electrons. No. B has more protons than neutrons. Definitely no. Has more protons than electrons. Yes. Has equal number of electrons and protons. Definitely no. Why is it definitely no on option D? Because that one is neutral. It's not even positively charged. Okay, so the correct answer in here is option C. Okay, so a positively charged object has got more protons as compared to what? Electrons. Okay. 1.9. Which one of the following graph illustrates the relationship between the current and potential difference for an ohmic conductor? Okay, for an ohmic conductor, that is the key there, because this is a conductor that obeys Ohm's law. Okay, so the relationship between the current and the potential difference, how would it be? Okay, we know that it has to give us a linear relationship, meaning that it has to be direct proportionality, because now, according to Ohm's law, the current, okay, across in a conductor is directly proportional to the what? To the potential difference across it at constant temperature. Okay, that means that the current has to have a direct proportionality relationship with what? The potential difference. Okay, so how then can we see that this is a direct proportionality relationship? Because it has to give us a straight line graph, a linear graph, if I may say. So amongst those four options that are provided, it's only option A that is giving us a linear or straight line graph. Okay, so definitely it is our correct answer is A. Let's look at the last one, multiple choice question 1.10. They say R1 and R2 are two resistors that are connected in parallel. Very, very important, because the way they are connected tells us what we know about how we can calculate the resistance, about how we can find the current, about how we can find the potential difference. Okay, so as shown in the figure, right? And they goes on to say the resistance of R1 is double the resistance of R2. Okay, so meaning that the resistance is here is higher. Resistance is higher, okay, as compared to the one of what? Of R1. So resistance here is lower. Okay, and the current, they goes on to say, and the current through R1 is I. So the current that is flowing in here is I. All right. So in as much as it has a higher resistance, which is double that of R2, okay, so the current that is flowing there is I. Okay, but now what is the question saying? The current through R2 is going to be what? Okay, so the current through that flows in here, okay, since here there is more resistance and still there's going to be I, and then here there's less resistance, that means that more current is going to be flowing in there, because now there is more path, there's less resistance, so current just flowing in nicely. So it has to be more than the one that is flowing through what? R1. Okay, so let's look at the options that we have. It's going to be half of I, definitely not, because it has to be more than I. Okay, and then B, it cannot be I, because the resistance is not the same between R1 as well as what? As well as R2. Okay, and then C, 2I. Yes, definitely 2I. Why? Because when we look at the resistance between the two, R1 and R2, they say it is double. They did not say it is triple the resistance. Okay, so it is double. So what is double? It means twice as much. And then because it's twice as much, there is our correct answer. Okay. Now let's look at the long questions, okay? And we're going to start off with the magnetism long questions, all right? This is taken from a question 8. We're going to start with question 8.1. They say a bar magnet has a pair of opposite poles called north and south, all right? So as we can see, the figure below shows a bar magnet with its poles, okay? Right, so we can see this north as well as the south. Right, let's dive into the question. They say the first one, define the term magnetic field. What is a magnetic field? Okay, it's a region in space where a magnetic or ferromagnetic material will experience a force. All right, so please learn to write your definitions fully, okay, so that you get those 2 marks. Remember, there is no part marking, it's just 2 or nothing. All right, so a region in space where a magnetic or ferromagnetic material will experience a force. Short, nice, and sweet. All right, let's look at the next question. They say, draw the magnetic field pattern around a bar magnet. Okay, so we had the north and the south. What is it that we should pay attention to? Always remember to pay attention to the way you're drawing your magnetic field lines. Okay, so they have to be more concentrated at the poles, okay, and then widely spread out in the middle of the bar magnet. Okay, that is one. Number two, direction is important. Okay, so you should let us know using the arrows in which direction are these magnetic field lines are going to. So they always have to be moving from the north to the south. All right. Also, you're looking at the shape that is giving. Okay, is it giving the proper shape that it should be giving when you are drawing it? So let's just draw it and look at all these things that we are exploring as we are talking to each other. So this is the north and this is the south. All right, and then I always say less is more. Okay, so that you don't make the mistakes of having these magnetic field lines to touch, because they should never touch. Okay, less is more. 2 at the top and 2 at the bottom definitely gives us an idea that really you know how to draw the magnetic field lines. Okay. So you can see that all of them are starting at the poles. They are concentrated. Then there's less of them as in the middle. The second thing, the shape, is it giving the shape that it should be giving? Okay, and then direction. Always the arrow moving from north to south. That means that in the middle over here, there should be arrows that are showing the direction of the magnetic field lines. Okay, and then now you go to the side ones. Okay, so then from the north we are exiting, okay, or we're departing, and then on the south, that's where you just continue and just to say this is where they're exiting, and then this is where they're exiting. All right, and then on this one they are entering, because they have to be moving from the north to the to the south pole all the time. So that's where these 3 marks are gathered, so that's how easily you can gather those 3 marks. So one, you're looking at the lines that they have to be more concentrated at the poles. You're looking at the direction as well as the shape. Right, so easy. As long as you stick to the rules, less is more. Draw less lines so that you are able to make them not touch, because also you need to make them nice and neat. All right. 8.2 goes on to say the north pole of the bar magnet is brought closer now, okay, to the south pole of another bar magnet. So you have the south that is being closer to the to the north pole of another bar magnet. All right, let's dive into the question. Is the force experienced, all right, by the magnet when they are brought closer, attraction or repulsion? This is where we have to remember that the like charges, or rather in this case, because we're talking about poles, the like poles would do what? Will repel, but the unlike, okay, will attract. In this case we have unlike, because we've got north on this side, and then we've got south on this side. So definitely it's going to be the force of what? Attraction. The reason is that unlike poles attract. Okay, easy peasy. Let's move on with our questions. 8.2.2. What will happen to the force if the distance between the poles is increased? So if the distance now between these 2 poles is increased, so they're no longer close to each other, so they are far apart from each other. Okay, so what happens to the force? Okay, so we say as the distance increases, the force, because now it was the force of attraction, right? The force of attraction decreases. As soon as we try to shift this bar magnets far apart from each other, you're less likely to feel any force in between them. But bring them closer, you'll feel the force of attraction that wants to pull these two magnets closer to each other. Okay. Explain how geomagnetic storm is formed. Okay, so now with geomagnetic storm, what happens is that a large bubble that is made up of protons and electrons is being ejected by the sun. Okay, so it is being ejected. To eject something is just to emit something. Okay, so it's being ejected by the sun, and it just goes straight towards what? The earth. Okay, so as it moves towards the earth, it finds that this earth is being covered now in what? In the electric, by the electric, the earth's what? The earth's magnetic field. Okay, so as this large bubble that is made up of protons as well as electrons is moving towards the earth, okay, it then joins up with what? The earth's magnetic field, that then just releases a large amount of energy, like an explosion kind of thing. Okay, so that is how geomagnetic storms are created. Okay, so a large bubble that is made of protons and electrons is ejected by the sun. Okay, and moves towards the earth, and moves towards the earth. Okay, this large bubble, okay, then joins this bubble, joins up with the earth magnetic field, okay, and then releases a large amount of energy, which we refer to as geomagnetic storms. So that collision from this highly charged large bubble that is being ejected by the sun, okay, that is going to collide with this protective layer of the earth, which is what? The earth's magnetic fault lines. Okay, then it's going to just release this a burst of large energy, which we refer to as geomagnetic storms. Okay. Question 9, it says two identically charged conducting spheres M and N on the insulating stands carry charges of positive 2Q and negative 4Q respectively. Okay, let's just pause in there. These are not coulombs. I cannot refer to them as coulombs because we know when we refer to coulombs, we refer to a bigger Q, like a bigger Q like that. So that's what charges would look like. Okay, so this one is just having a positive 2Q and a negative 4Q respectively. Now the spheres are placed 20 millimeters apart. Remember, you have to do your conversions every time you see something that is you're not familiar with. You're like, okay, I'm not used to having the distance between the two spheres being in millimeters. You're like, okay, they have to be in millimeters, and then you do your conversions properly. Okay, let me just take you through to how we do the conversions. So remember, you've got your kilometer, and then you've got your meter, you've got your centimeter, and then you have your millimeter. Okay, so over here, if you're trying to move from kilometer to meter, then we have to times it by what? 8,000, and then from meter to centimeter we times it by 100, and then from centimeter to millimeter we times it by 10. All right, but now when we have to move now from this millimeter, which is a smaller SI unit, to the bigger one, we have to divide by the same factor, which in this case is going to be 10, 100, and 1,000. Okay, so from millimeter now to centimeter, we're looking at the errors, is going to be dividing by what? By 10. All right, and then from centimeter to from centimeter to meters, then we have to divide by 100, and then from meters to kilometer, we need to do what? To have to divide by 8,000. Okay, so that's how we should be doing it. Now looking at, because now you're moving from a millimeter, which is over here, and you want to get to a meter, okay, you need to then count how many zeros did you skip. Okay, first things first, before you even count the number of zeros that you did skip, okay, you look at which direction you're moving to. Are you going to do a multiplication? Are you going to be doing a division? And the answer in this case, because you're going in that direction, you're going to be doing what? A division. Okay, so you have to divide the 20, okay, not multiply it. And then the second thing, by what factor? 1, 2, 3. So you skipped 3 zeros for you to be able to get into the SI unit that you want. So that means over here we have to say 20. Let me just remove this Q over here, divide by 8,000, which is going to give us what? So 0,02 meters. Okay, so now we'll successfully be able to convert from the millimeters to what? 2 meters. Okay, and then the statement did not end there. They said the spheres are placed 20 millimeters from each other, as shown in the diagram. The force exerted by M on N is 6,840 newtons. So this is the force. Okay, because we can even see they told us the force that is exerted of an by M on N is 6,840. Then they gave us a nice diagrammatic representation so that we get able to view what is it that we are speaking about. All right, please make it your habit to read the instructions carefully, okay, before attempting to answer the questions. Okay, so I brought this closer with us so that we are able to just take a look at it nicely. All right, so let's look at this one. They said state Coulomb's law. Okay, so all or nothing, state it nicely, don't leave anything out, then you are going to be awarded your 2 marks. Okay, so Coulomb's law state that a force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Right, so study that list and then you get your 2 full marks. Okay, looking at a different question, they say calculate the magnitude of charge Q in coulombs. Okay, so what is it that we do know? Let's first write the formula as it is. We say F is equals to K Q1 Q2 over R squared. All right, so because that is Coulomb's law, but now using a formula or symbols. All right, and then we are given the force. All right, the force was what? Let's just go back a little bit. It was 6,840. 6,840. Okay, what happened to my thingy? Trying to minimize it. Let me try and exit, but I'm struggling. Now, yes, it's back. 6,840. So over here, we have 6,840. Okay. And then we have a constant of 9 times 10 to the power of what? Of 9. Please, this one will just be given to you alongside the formula sheet. Okay. And then for the first charge, it is what? We're giving it here. It is 2Q. Don't worry about the charges as you are doing your substitution. Okay. So this is 2Q multiplied by 4Q. So you will see that I didn't put any positive or negative. I just put the magnitude of it. Okay. Because by the nature of the fact that they told you this one is positive and negative, you can tell that this is going to be what? A force of attraction. Okay. And then divided by this distance between them. Already you've done conversion of this 20 millimeters to be what? To be a 0,02. Okay. So this is going to be 0,02. And then we square it up. Okay, most people forget to square it up. Please, it's important. All right, so we're just going to find the values that we're going to have in the numerator as well as the denominator. Okay, we still bring the 6,840, and then we say equals to, then you say 9 times 10 to the power of positive 9 multiplied by 2 multiplied by 4 is going to give us a 7,2 times 10 to the power of what? To the power of 10. All right. And then divided by what is then 0,02 squared. Okay. This is going to give us what? 0,00. How many zeros after the comma? There's going to be 3 and then 4. Okay, because now you have a fraction on the side and then you have only a number on there. It's just you just need to do what? To cross multiply. Okay, don't forget here at the top you had multiplied 9 times 10 to the power of 9 2 times and then times 2 then times 4, but don't forget these q's because those are your unknowns. That's what you are calculating. That's what you are trying to find at the magnitude of q. So because now the bracket means multiplication, so q times q is going to give us what? Q2. So that's going to be like reading 7,2 times 10 to the power of 10 q squared. All right, and then cross multiply. That means when you cross multiplying, you are multiplying 1 times that value. Okay, I'm just going to write it here so that it is visible enough. So we're going to have now 7, write it at the top a little bit. So it's going to have 7,2 times 10 to the power of what? To the power of 10 and then q squared, right, is equals to, and then what is 6,840 multiplied by 0,123, and then it's going to give us 2,736. Okay, so then now you're trying to find q squared and not just 7,2, so you have to divide by on both sides by 7,2 times 10 to the power of positive 10 on both sides. 7,2 times 10 to the power of positive 10, so that is cancelling that, and this side you are left with q squared. Okay, right, and then you divide by 7,2 times 10 to the power of 10. It's going to give us 3,8 times 10 to the power of negative 11. Square root of that. Introduce a square root this side, a square root that side, because we don't want q squared to 1q. Then it's going to be q is equals to, it's giving me in decimal, but if you get it using your Casio, this is what I'm using. I'm using my Sharp. It's going to give you in a scientific notation, which is totally fine. Okay, it's just the way that it is written. Mine is giving me in decimal numbers, and then yours can give you in what, in scientific notation. Leave it as it is, continue with your answer. So Q is 0 comma, how many zeros of there come? 1 2 3 4 5. So 1 2 3 4 5, and then 616 4, and then coulombs. Okay, so this is the magnitude that we wanted, because the question I was saying calculate the magnitude of charge Q in coulombs. Okay, so here it is. We have found the magnitude of charge Q in coulombs. Okay, so the things that I wanted you to pay attention to with regards to this question, please make sure that you do your conversions before you use your formula. Okay, so that by the time you get your answer, you get it correctly. So okay, your distance needs to be in meters, your force needs to be in newtons, your charges needs to be in what? In coulombs. Okay, so if they are not in like that, then you need to do something. You need to do your conversions before you even start with your calculations. 9.2 is saying X and Y are two parallel plates placed at a distance of 10 millimeters apart. Okay, let's just pause in there. The distance we just mentioned, it has to be in what? It has to be in meters. So again, we have to say 10 divided by 8,000, because we're moving from a smaller unit to a bigger unit. So this is going to give us a 0,01 meters. Okay, so after conversion, well, what did we do? We divided it by 1,000. Okay, now a charge of positive 6 microcoulomb is placed at a point M, experiences a force of 0,21 newtons. Okay, so this is the force that is experienced by this charge of positive 6 microcoulombs at point M. Right. Let's look at the questions that follow then. Define what is it, what is the term electric field? What is an electric field? Okay, so it is the region in space where a charge will experience what? A force. A region in space where a charge experience a what? A force. Okay, and then we look at the following question. What is the direction of the force experienced by the positive 6 microcoulomb charge? Okay, the direction of the force. Okay, what is the direction of the force that is going to be experienced by the charge? Is it going to be towards Y or towards X? This needs us to remember the direction, okay, of the electric field in the parallel plates, because these are parallel plates. Okay, so I have a positive plate and then a negative plate on one end. Okay, so is it going to be towards Y? That means that it is starting from the positive end to the negative end, or is it going to be towards X, meaning that it's starting from the negative end to the positive end? Okay, so we need to remind ourselves that the electric field lines in a parallel plate, they always have to move from the positive to the negative. So it has to be definitely towards Y. Okay. And then 9.2.3, calculate the potential difference across the plates. Okay, so the potential difference across these plates, how can we then best calculate it? Okay, so let's write the data first. What is it that we do know? Before we even continue, we do know the force is what? Is 0,21 newtons, if I'm not mistaken. Let's just go back a little bit. So to confirm, yes, right there in the statement that was given to us, it is 0,21 newtons. Okay, and then do we know the electric the E part of it? No, we're going to find out but we do know about the charge. Okay, so the charge is positive 6 microcoulomb. That means we need to convert it, because the micro part, it means that times 10 to the power of minus 6. So this is times 10 to the power of minus 6 coulombs, and right there we have changed it from being microcoulomb to being coulomb. Okay, so if it was nanocoulomb, we'll say times 10 to the power of minus 9. Okay, so using this information here, we're able to find the electric field strength, okay, which we are going to use next to be able to find the potential difference, so that we are able to attempt or answer the questions properly. So we're going to start by saying E is equals to F over Q, and this formula is there in your formula sheet. Okay, you just need to know the relationship between all the physical quantities that are there on the formula, that the electric field strength is directly proportional to the what, to the force. All right, so here our E is unknown, but we do have a 0.21 newtons divided by a 6 times 10 to the power of what, of negative 6. So we just punch this in our calculator, 0.21 divided by 6 times 10 to the power of what, of minus 6, and then this gives us 35,000. Okay, and all right, so this, the units, because remember on top on your numerator this is your newtons, okay, and then your denominator is your coulombs, so it's newtons per coulomb. Okay, however, we have not answered the question the way we should, so we just use another equation and say, okay, what is it that we have now? We do have the electric field strength, so that means we can use the formula E is equals to V over D, because we are trying to find the potential difference across these two plates. Okay, so this one we have a 35,000 is equals to what we want to know, okay, divided by the distance, and then we remember we calculated to be what, to be 0.01, okay, cross multiply by making this to be over 1. So this is going to be 1 times V, which is the potential difference which we want, is going to be V is equals to, then we say 35,000 multiplied by 0.01 is going to give us a 350. Okay, this is in volts. Please don't forget to write your SI unit, because you cannot be just saying 350, because we don't know whether you're talking about trees, you're talking about eggs, you're talking about pen, you're talking about calculators. So your SI units are very important to signify what is it exactly that you are speaking about. All right, and then this is how simple you are going to be able to do it. Okay, what are the points I need you to take away from the slide? Please, if you're unsure about how to go on about doing your calculations, please write your data first, just like we did here, so that you can say, okay, what formula can I use? What is it do? What are the physical quantities do I have? Okay, how can I get into the answer on based on what I'm being asked? Okay, please, all the time, just remind yourself on how to get to your answer. Okay, and then question 10 deals with electric circuits. Okay, they say in the circuit shown below, the resistance of R is unknown. Okay, if now the EMF of the battery that is being provided is 24 volts, all right, ignore the resistance of connecting the wires as well as the ammeter. Okay, so study the electric circuits that is being given to you. Study which ones are parallel, which of the resistors are connected in series, which one of the resistors are connected in parallel, so that you are able to have a clear mindset on how to then best answer the question to your best optimal level. Okay, so you have a switch over here. You've got the EMF, okay, potential difference that is being supplied by the battery when no current is flowing into it. Okay, and then we've got 12 ohms. We've got 10 ohms that is parallelly placed with the unknown resistor R, and then you've got 12 ohms that is connected to a voltmeter, and then you've got your ammeter. All right, let's attack the questions. Right, now they say when the switch S is closed, the ammeter shows a reading of what? Of 0.89 amperes. Okay. State Ohm's law in words. It's all or nothing. State it correctly, then 2 marks. Don't state it correctly, 0 mark. There's no part marking. So it says that in a conductor, okay, let's just start with, say, current in a conductor is directly proportional to the potential difference across it at constant temperature. So this is also given in a formula to be what? V is equals to IR. Okay. And then remember that is a skill to say, okay, if you happen to forget how to correctly state the laws, then you can look at the formulas that they write in terms of the Ohm's law, and then you can say it in words. So use your formulas to be able to say or to write your laws in words correctly. Okay, and then the next one is saying 10.1.2, calculate the resistance, okay, the total resistance, that is, of the circuit. Okay, what is it that we do know? Data is over here. So we do have the EMF providing what? How many volts? 24 volts for the entire circuit. And then we do have I to be what? 0.89 amperes. But we don't know R. Okay. So we make it RT because we want to find for the entire circuit. So this makes it easy because we know V is equals to IR. Okay, and this is 24 over here is equals to I, which is our current, is going to be 0.89, and then amperes, that is, and then we have RT over here, which is standing for the total resistance. Okay, so we divide by 0.89, divide by 0.89, so that we remove what we don't want, and we are left with the resistance in total, or total resistance. So we say 24 divided by 0.89, and then it gives us a 26.96. Therefore, never leave it like that. So therefore, RT is equals to 26.96, and because it is a resistance, okay, total resistance has to be in what? In ohms. Okay. Simple as that. All right. 10.1.3 is saying calculate the resistance of R. Okay, so we want to know the magnitude of this R over here. Okay, how best can we do this? Okay, so what is it that are we going to do? Let's just find the R total, because we already know that R total is 26.96. Okay, we just calculated it. But now if we were to add all of them, okay, let's just say R total is equals to R1. Okay, in this let's just not give them R1, just give them their magnitude, so that you don't get confused, because it's not a formula. We're working with what we are given. Okay, so RT is equals to this resistance, which is 12 ohms plus, and then we've got these two, but then they are connected in what? In parallel. So plus R parallel. And then we have this one over here. Then plus R, no, because it is given to be what? 12. Okay. All right. All right. And then on the next step, I'm going to substitute for RT, because the total resistance we've already calculated in the cell. It is what? We said it is 26.96 is equals to Now let's just add like terms together, right? 12 plus 12 is going to give us what? 24 plus R parallel. Okay. Now let's transpose. So we're going to say 26,96 minus, because this one we bring it on this side. Okay, so as it jumps the equal sign, we call it transposing, so we change the sign. So it's going to be negative 24 is equals to R parallel. Okay, so 26,96 minus 24, what is it giving us? It's giving us a 2,96, okay, is equals to R parallel. Therefore, we do know that R parallel, okay, let me just draw the lines because we've been doing that, is equals to 2,96 ohms. However, this does not answer or give us an answer to what we are being asked, because now we just know that together this makes 2,96. However, we have not answered what is the magnitude of this resistance over here. Okay, so what do we do? Okay, we said, okay, let's do it again. So what is the formula I can use so that I can be able to substitute the resistance in parallel? I said 1 over R parallel is equals to 1 over R1 plus 1 over R2. Okay, and then I do have 1 over this, then I'm substituting over here. Okay, this is my R parallel, which is what? 2,96. All right, is equals to 1 over R1. R1, I know it to be what? To be 10, because there are two of them. So there's one at the top and one at the bottom. Okay, so if I refer to R1, 1 and 2, because there are two resistors that are in parallel to each other. So this is going to be 1 over 10 plus 1 over R2. So because I'm trying to find this R2, okay, same procedure, we transpose. So we're going to say 1 over 2,96 minus, because this I'm putting on this side, so it's going to be 1 over 10 is equals to 1 over R2. Okay, so what is 1 over 2,96 minus 1 over 10? It's going to give me a 44 over 185, and I want it like that because it is given in what? In a fraction form, is equals to 1 over R2, because this side is given in a fraction form. So you just say simply 44 times R2 is going to give us what? 44 R2 is equals to 185 multiplied by 1 is going to give us 185. Okay, and then divide by 44 on both sides, so that 44 cancels that 44. You have R2 is equals to 185 divided by 44. It's giving us a 4,2 ohms. Okay, now we know that the magnitude of this R2 is what? Is 4,2. All right, nicely done. Eh? So let's move on. This is how you get yourself that 5 marks. 10.2, write down the reading on the voltmeter when switch S is open. Okay, so when that switch S is open, okay, there I mess it up again. Let me try and find back. Yeah, okay. When switch S is open, what is going to be the real thing on the voltmeter? It's just going to be 0 volts. Okay, so because now there is no current, there is no use of this voltage that is being offered there. Okay, so there's no current that is being flowing in here. All right, so it's going to be 0 volts. What is the total amount of work done to move 1 coulomb of charge through the circuit. Okay, remember, in the circuit, we are being provided with an EMF of what? Of 24 volts. Okay, so the work that is done to move this 1 coulomb of charge through the circuit is therefore going to be, because now we're referring to work, and work is in joules, so we need to say it's 24 joules. Okay, what will happen to the reading on an ammeter if R bends out? Okay, the one that we just found to be 4,2. Okay, so if it bends out, okay, that resistor that was unknown before, so if it bends out while switch S is closed, okay, meaning that the current is flowing. Okay, write down increase, decrease, or remain the same. What will happen to the reading on the ammeter? Okay, so ammeter, it reads what? Current. So when now, if the R bends out, okay, the one that is worth 4,2, okay, if it bends out, what will happen? So it will, the ammeter will, or rather the current or the reading on the ammeter will decrease. And I'll tell you why it will decrease. Okay, because now, let's just go back so that we are able to look at it nicely. So if this one is burned out, okay, that unknown R that was unknown before and that we found later to be what? To be 4,2 ohms. So if it bends out, and it, because now before it bends out, the parallel resistance was what? Was 2,96. Okay, but if now it bends out, it rules out the fact that we have to calculate the resistance in parallel. Okay, then we need to take into consideration what? Only the 10 ohms. That means that the 12 ohms, the 10 ohms, and the 12 ohms are now connected in what? In series. Okay, so instead of that what? Of 2,96 that we had here, we no longer have it, but we have now what? 10 ohms only. Okay, so now there's an increase in the resistance of the circuit, the entire circuit. Okay, hence the reading in this ammeter is going to do what? Is going to decrease. Okay, why? Because there's been an increase in the resistance. The current is now unable to flow nicely. There's too much resistance in the circuit, so the current that is going to be read is going to be less. Okay, so that is why we're saying it will decrease, because now the total resistance increases. Okay, 10.5, they say a group of learners conducts an experiment to determine the internal resistance of the battery. All right, so what they do, they set up a circuit diagram as shown in the figure below. The battery has an internal resistance R and then an EMF of what? Of 12 volts. All right, so analyze the circuit before you jump into the questions. Okay, so we got a closed switched, and then we've got ammeter, and then we got a resistance, and that is not given. Okay, as to its magnitude, and then we've got the internal resistance. Okay, remember, with technical sciences, we don't ask you to calculate the internal resistance, but we do need you to be able to know what it is. Okay, so remember what I just said, we do need you to know what it is. That is why 10.5.1 says define the term internal resistance of the battery. Okay, so it is the resistance provided by the battery when, okay, let's write it down. So it is what? Resistance provided by the cell or battery when the current flows through it. All right, and then 10.5.2. What is the reading on the voltmeter when switch S is open? Okay, so it will not decrease. The EMF that is provided by the cell will not decrease, because now there is no current that is flowing onto it. Okay, so still it will be what? It will be 12. Let's check it out what it was. It was 12 volts, right? So still the reading on the voltmeter will still be what? 12 volts. Okay, because the switch S is open. Only when the switch S closes, then the 12 volts will be utilized inside the electric circuit. Okay, then it will decrease from being 12, because now the energy is being used. Okay, and then what will happen if the reading what will happen to the reading when switch is closed? Okay, so the voltmeter reading when the switch S is closed, and then write down increase, decrease, or remain the same. When now the switch is closed, okay, what will happen to that reading, the voltmeter reading? It will decrease. Okay, why? Because energy is being utilized inside the in electric energy provided. Rather, let's say the potential difference. Potential difference offered by the cell is utilized in the electric circuit. So there will be lost volts due to the fact that now current is flowing, now potential difference is being utilized. The EMF that is being offered into the electric circuit is being utilized in the electric circuit. Okay, so that's how simple it is to answer these questions. So I want to end today's lesson, and before I even end it, I hope you had fun. I hope you had clarity on the questions that you were uncertain about, and then you're going to crack that paper 1 exam. Okay, so I want to end today's lesson by a quote by Albert Einstein, which said we cannot solve problems with the same thinking that we used to create them. So I hope we change our mentality, our way of thinking, so that we can be able to solve as many problems as we possibly can. Okay, have fun while studying. Okay, don't forget to have fun. Have fun while studying, so that it doesn't feel like a burden, but it feels like a habit. Okay, like a hobby. Okay, have fun. Thank you for joining us. Hope you join us next time as we try to solve all the problems regarding paper 2 content. Okay, have fun. Bye.